Hello everyone, my name is He Jing, and this is my first project for the parametric modeling. The first part will be the project information. As you can see in the photos, this project is a pavilion for a natural concert hall. And for me, the most challenging part is to build the structural metal frame and the fabric facades, which are the rotating curtains. For the second part, I'll go through the process of building the parametric form. So this is my final model, which includes 4 parts. The first part is for the structural frame, the second part for roof, third part for the facades, which are the rotating curtains, and the last part for the base. And I get everything from this rectangle, which I have full control of the dimensions. As you can see here, if I move it, everything will move it. Okay. And first I'll close the other parts, just show the structural frames. I get all these frames from the baselines. It starts with this rectangle, of course, and by moving it, get higher level of the same rectangle. And by finding the central points, midpoints, also some end and start points. Also, I changed a bit of the tree structure so I can get the points to connect as I wish. So finally, I got all these baselines. And from here, I just got which I call the primary frames. That's the main structure that supports the pavilion. And from these lines, I get this secondary frames here, which work between the primary frames. And then I gave a volume of all these frames that makes them look more realistic. I just set a section for each of these baselines, and then by extruding, I get all the frames. So the next step is for the roof for the pavilion. And first I just pull out some of the baselines that are already built in the former step. To make it more clear, I'll just close those parts. So this part, as you can see here, the green lines are lines I pull out for the roof. And then I change the tree structure of the data so I can get all these boundaries for each of the triangular shape into the same group. And with those boundaries, I can form these triangular surfaces as the roof. I think there could be better approaches to get the same result, but here is just how I solve this problem. So here comes the most challenging part, that will be the rotating curtains. First, I'll just get this frame back. And then for the curtains, first I get the facade as a whole surface by extruding, and then divided it to get all those points for the future curtains. Simply get the bottom points for all the curtains as well as top points. So if you look at photos carefully, you can see all the top points for each curtain are actually fixed to the frame, while the bottom points are not fixed, and that's the part to be rotated and controlled. So the top points is actually easier. I just need to connect those points by very short lines, which will be the top boundary of each curtain. Here, I just use the shift function to connect them. But if I just do that, the first point will connect to the second to the third, and then the last point will connect to the first, which will make an actual line that I don't need. So here is just how I get rid of it. And then I could get all those short lines here. And for the bottom part, it actually works the same. But here I need to use this curve closest point to get this perpendicular line as the bottom boundary of each curtain. Let's check if we can get each curtain right here. See, all the curtains are here. But those curtains won't rotate, so let's work more on it. So this part, I'll get a series of rotating degrees for the bottom lines to rotate. To get that, let's get rid of this. Okay, here, as you can see, we get these lines to rotate. And another problem I solved here is that I get all the lines with a positive rotating degree to rotate, while the lines with a negative rotating degree to stay the same here. So here is how I get that. So these lines or these curtains here will stay closed. So if I change the degrees here, you can see, get better width. You can see I can change how many curtains are actually rotating. Just set any point. And then with all these bottom lines and the top lines we get earlier, we can just simply use loft to get all these rotating curtains, as you can see here. Again, I can change this difference in degree between adjacent curtains here to change how many curtains are rotating and the degree for them to rotate. So this part is how I get those rotating curtains. The last step is just to get the base. That's a very easy part. Just use boundary to get a surface and then extrude it to get this triangular shape base. So the model is completed. In the third part, I'll add physical elements to the existing model. And this part is how I get the kangaroo to work for the physical elements for the whole design. First, I just simply add one mesh here. So I will form a roof using the U-force and the springs. And also I get my anchor points as all the naked point and the central point. So I can then fix it to the frame and get a right roof for the structure. So if I make it to work, and then I can get this mesh. So this is all I get roof, and then I just move those anchor points to fix it to my design, to pavilion, and then the roof will get this look. So I get this curved lines as a new roof. So that's all for my parametric modeling project 1. Thank you for watching this video.